Hello, Precalculus. Welcome back to 9.2. I don't know why that thing keeps popping up there. All right, we're on 9.2, number 15. We've got r squared is equal to 16 cosine 2 theta. Anytime I see r squared, I know we are talking about a lemniscate. I had a student last year talking about these being lemon skates. So I'm going to do it in yellow in honor of him. All right, and if we're talking about cosine, we know we're going to be symmetrical about the polar axis. When we graph this, you're going to see we've got a couple other symmetries, but right now we're just going to say polar axis. All right, for our maximum R values, well, we know cosine 2 theta oscillates between -1 and 1. So if cosine 2 theta is -1, then be careful. R becomes, this is R squared, so R becomes the square root of 16 times -1. Well, is that possible? No, this does not exist. And if cosine 2 theta is +1, r becomes the square root of 16 times 1. 16 times 1 is 16. Square root of 16 would be 4. So my maximum r value is going to be 4. Well, when does that occur? Well, let's plug 4 into this equation and see what makes it true. So 4 squared is equal to 16 cosine 2 theta. 4 squared is 16 is equal to 16 cosine 2 theta. Dividing by 16 on both sides, I get 1 is equal to cosine 2 theta. All right, so then that would be, when is cosine equal to 1? Well, that's at 0, right? But keep in mind, because of 2 theta, we have to go around and add 2 pi to it one time. So it's at 0 or 2 pi. And then when we divide by 2, that means we're at 0 or pi. So this is at theta equals 0 or pi. And then for our zeros, we want to know, when is this guy equal to 0? Dividing by 0 or by 16, I still get 0 is equal to cosine 2 pi or 2 theta. So 2 theta would be whenever cosine is equal to 0. Well, that's going to be at pi over 2 and 3 pi over 2. But we got to go around our circle one more time. So adding 2 pi to pi over 2, I get 5 pi over 2. Adding 2 pi to 3 pi over 2, I get 7 pi over 2. So our zeros will be when theta is equal to pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. So we know this is kind of that infinity looking symbol. We know it should be symmetrical about the polar axis. Notice at 0 and pi, we're going to be at r equals 4. So here and pi, we're out at 4 as well. And notice that pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. So pi over 2 would be here. We're at 0. And 3 pi over 2. And then 5 pi over 2 and 7 pi over 2 would be the same thing. So what happens is we start graphing at 0, and it comes back like this. Goes down. Oh, overshot that one a lot. And makes an infinity kind of symbol. And it comes down and does it again. So notice it's very much like a rose, but it's missing 2 petals. Any guesses why we're missing 2 petals there? Hopefully you see it. Hopefully you see that, because when it's supposed to be -1, so down here and maybe up here, where it doesn't exist. So that kind of makes us lose those petals that would be up there. Now, I told you earlier this would have 2 other symmetries. So yes, we are indeed symmetrical across the polar axis because this half looks like this half. But do we have any other symmetries? Yes, we do. This half looks like this half. So we're also symmetrical about theta is equal to pi over 2. And we are symmetrical about the pole. So lots of symmetry for this lemniscate. All right, that's number 15. I'm going to do one more video for today and then call it quits.